Welcome to Pure 2, Chapter 5.5. This is the last chapter of radians, and actually, it's a very light one. It's going to be a quick one. So let's have a look. We can use radians to find approximations for the values of sine theta, cos theta, and tan theta. So when theta is very small, think of values like 0.0001, and we measure in radians. Now, if you have a calculator, can I ask you to take it out and we'll do a small experiment, I guess, investigation together. So make sure calculate in radians. So the radians, the top should be in R, not D. D stands for degrees, so radians. Now, if you try to put sine 5, you get quite, negative 0.9589, nothing special, right? Okay, let's try put a small number, sine 1. You say 0.84147, still nothing special, but you can see this number is getting closer than 1 to 1, closer to 1 than it was from negative 0.95 to 5. Now, what if we put an even small number, negative 0.5, sorry, sine 0.5, 0.479. Again, it's getting closer to 0.5. So it's almost like 0.5, but it's not. What if sine 0.1, 0.0998, 0.998, that's nearly 0.1. What about sine 0.05? 0.0499. So that's almost 0.9, not 5. So what can we say for sine theta when theta is small in radians? Now, these are given the formula booklet, so don't worry. Okay, so these are given the formula booklet. So when theta is small, then sine theta roughly equals approximates to be theta. So e.g., so they're all given formula booklet, okay, and cos theta is roughly equal to 1 minus theta squared over 2. And tan theta will be same as sine theta, roughly equal theta. So these are given, all given in the formula booklet. Okay, not Facebook. For some who are of a certain age, FB means Facebook, but no, FB means formula booklet. So EG in here, I'll give you a small EG in here. If you have sine 0.05, that roughly equals to 0.05. If you have cos 0.05, that roughly equals to 1 minus 0.05 squared over 2. Okay, and 10 0.9, 0.05 will be something similar, will equal to 0.05. So we can use this approximation. The question will tell you when the question say, okay, when theta is small or using small angle approximation, then this the Q when you have to use these formulae, I guess. Okay, right. So example, when theta is small, okay, find the approximate value of sine 2 theta plus tan theta over 2 theta. So question A, so you can see when theta is small, that's the cue for you to use the small angle approximation. Okay, like when you're hungry, you go and get fish and chips or just chips, no fish. Question A, okay, so sine 2 theta. So we know sine 2 theta. I'm just going to rewrite the question just to make it easier for you to see what's happening in between. So we know sine 2 theta, that's sine theta roughly equal theta value. So whatever we're signing, I guess signing, we use that value. So sine 2 theta roughly equal to theta, and tan theta roughly equals to theta. So therefore, we can write our final answer as it approximates to 2 theta plus theta over 2 theta, which now equals, now y equals, because this approximate this one, but this one now equals the next step because we're no longer approximating the next step. It's something quite technical, but it doesn't matter whether you put a roughly equal in here or equal, but the first one must be a roughly equal, okay, must be approximate. So 3 theta, 2 theta plus theta is 3 theta over 2 theta, which is same as 3 over 2. Okay, right. Part B. Cos 4 theta, I'm going to rewrite cos 4 theta minus 1 over theta times sine 2 theta. So cos 4 theta, okay, recall that roughly equals to 1 minus 4 theta. Oh, actually, I shouldn't write there. I shouldn't write there. I shouldn't write there. I'm going to put it in here. Roughly equals to sine 4 theta is the same as 1 minus theta squared over 2. But theta is now 4 theta. Okay, minus 1. So just to make you aware, this is this. Okay, over theta times sine 2 theta. Sine 2 theta is theta. So just to make you aware, Again, this sine 2 theta. Oh, I made a mistake. Should be 2 theta in here. Okay. Right, then I'm just going to simplify the numerator in here. So 1 minus 4 theta squared, 16 squared, 16 theta squared, divided by 2 is 8 theta squared, minus 1 over theta times 2 theta squared. 1 minus 1 is gone. So negative 8 theta squared divided by 2 theta squared is negative 4. Right? And yeah, that's it. So when theta is small approximation, you just use the formula correctly. Okay. Now, if you want to have a go at this example, feel free to try it, example. But if you still want to listen and you're not too confident, then you can go on. Right, example A. Show that when theta is small, again, the Q is here, theta is small, so use small angle approximation. Sine 5 theta plus tan 2 theta minus cos 2 theta approximates to 2 theta squared plus 7 theta minus 1. So left-hand side, okay, so left-hand side equals to sine 5 theta plus tan 2 theta minus cos 2 theta, which is sine 5 theta is same as roughly equals 5 theta, tan 2 theta is 2 theta, but cos 2 theta is 1 minus 2 theta squared over 2. There are two brackets you need to put. One is this one outside, because when you do subtraction, the minus will play an effect of the minus, will interact with the minus inside bracket. Second of all, 2 theta, when you apply the cos theta small angle approximation formula, you must put a bracket around here because it's the whole theta value, whatever we're cosing, and a square. Cosing, not cussing. Next one. 5 theta plus 2 theta is 7 theta. Minus 1, minus makes a plus. 2 theta squared is 4 theta squared over 2. That gives us 7 theta minus 1 plus 2 theta squared. The question wants us to put a 2 theta squared first, so we'll do that. Be a good person, follow the instruction. And part B, okay, part B. And hence, state the approximate value for sine 5 theta plus tan 2 theta minus cos 2 theta. So now when theta is small, okay, so now when theta is small, now when theta is small, that means think about theta being a very, very small number, not 0.1. Okay, so 0.01. Now when you substitute into here, okay, then 2 theta squared will tends to be 1. Tends to be 0, tends to 0. I'll write this down for you. This means 2 theta squared tends to 0. That means when theta being a very, very small number, we're approaching 0. But unless theta is 0, then 2 theta squared is then 2 theta squared will become 0. So I will say again, when theta is 0, then 2 theta squared is 0. But if theta is not 0, which is here the case, theta is just a very, very small number. It's still technically not 0. When you multiply, you still have a value, just a very, very, very small number, close to 0. So we say 2 theta squared tends to 0. Now, what about same as 7 theta? That's the same thing. Because when you put a number, 0, you get 7 times a very small number, it tends to 0. Okay. Now, so therefore, 2 theta squared plus 7 theta minus 1, it tends to 1. It tends to minus 1. Because 0 plus 0 minus 1, which is minus 1. And that's the answer. Okay. And that's the end of lesson, really.